Today's daily LeetCode problem of the day is robot collisions, number 2751. Before we start with this question, I recommend, if you want to try an easier version of the problem, try out asteroid collision number 735. It's similar. So for this problem, there are one indexed, means it starts at 1, robots, each having a position on a line, health, and movement direction. We're given 0 indexed, meaning it starts at 0, integer arrays, position, health, and a string directions. Directions of I, or the character at I, is either a L for left or R for right. All integers in positions are unique. All robots start moving on the line simultaneously at the same speed in their given directions. If two robots ever share the same position while moving, they will collide. If two robots collide, the robot with lower health is removed from the line and the health of the other robot decreases by 1. The surviving robot continues in the same direction it was going. If both robots have the same health, they are both removed from the line. Our task is to determine the health of the robots that survived the collisions in the same order that they were given. Otherwise, the final health of robot 1, if survived, final health of robot 2, if survived, and so on. If there are no survivors, return an empty array. So we're returning an array containing the health of the remaining robots. Actually, we're returning a list. So in example 1, we can see what it means by the output. So in example 1, we are given the positions 5, 4, 3, 2, and 1. Obviously, in an actual line, it's going to go 1, 2, 3, 4, 5. But we want to return them in the original inputted order. So because they are imported 5, 4, 3, 2, 1, they're all moving to the right, so no collisions occur. Then the healths are going to go from 5, then 4, then 3, then 2, then 1 in the output. So 2, 17, 9, 15, 10, 2, 17, 9, 15, 10. Example 2, our positions are 3, 5, 2, 6. So the positions can be out of order, so that might be something we want to sort, so that way we can address the collisions as they occur in order. But we still want to track their original positions because that's how we want to return them. So for this problem, we're going to use a stack. And the stack is going to be useful to help us monitor collisions and track the health of the robots as the collisions occur. However, we are only ever going to push right moving robots onto the stack. So only push right moving robots to a stack. To handle left moving robots, what we're going to do is, for the left moving robots, use a while loop as their health is greater than 0 and the stack isn't empty. It will collide with everything currently in the stack. So what does this mean? As long as our stack isn't empty, because it's full of right moving robots, if, let's say, robot 4 was a left moving robot, robot 4 would have to go through robot 3, if robot 4 was a left moving robot, he would have to go through robot 3, robot 2, and robot 1 before he finishes meeting the robots that he will collide with. Right moving robots just have to wait for any left moving robots to the right of them to come collide with them. If there's a left moving robot to the left of any of these guys, they'll never collide with anybody. So we're only pushing right moving robots onto our stack. Left moving robots will use a while loop to determine their health. As long as it's greater than 0 and the stack isn't empty, it will continue to collide with whoever is in the stack until it is empty. Until it's either empty or the robot loses the battle based on its health. Okay, let's first start by initializing some variables. We're going to have an integer n, which is equal to the positions.length. We're then going to have an integer array could call this OG positions equal to a new integer array of length n. We're going to have a list of integers. We could call this the output, and that's equal to a new array list. And then we're going to have a stack of integers. This could just be s. This is a new stack. So the first thing we want to do is take note of the original positions of the robot, because this is how we're going to want to return them. So for int I is equal to 0 as long as I is less than our total length. Then because our robots are on a one indexed line, we could start by going plus plus of I. Then simply what we're going to do is mark our OG position of I is equal to I. Now, like I was saying, we might want to sort our robots because our positions aren't always going to be in order. But now we have OG position and positions. So how are we going to sort it? We can use the arrays.sort function, and we're going to sort our OG positions. But we're not going to sort the OG positions themselves. What we're going to sort is the positions variable. We're going to connect OG position and positions using arrays.sort by doing this. We're going to do R1 for robot 1 and R2 for robot 2. Sorry, what just happened? R2 for robot 2. And we're going to compare these robots using integer.compare. And we're going to compare the position of robot 1 and the position of robot 2. This will sort our OG position variable by comparing its position's counterpart. So after we're done doing that, what we can do is then iterate through our array and compare each of the robots and determine who's going to win in the collisions. So for int index in each of the OG positions, we could do I actually. For int I in each position, first thing we're going to want to do is we're always pushing right moving robots onto the stack. So what we can do is if directions dot char at I, sorry, if the directions dot char at I dot if the character at I is equal to an R, then we can simply just push this right moving robot onto stack. Otherwise, if we do not have a right moving robot, what we're going to want to do is compare our left moving robot to every robot in the stack until our left moving robot either loses, dies, or beats everybody and the stack is empty, and then we just need to monitor his health. So while our stack isn't empty and the health of the current indexed robot, I, is greater than 0, we are going to pop our top robot to compare. So int top is going to be equal to stack.pop. This is going to retrieve the health of our top robot. And if or that's going to retrieve the index of our top robot so we can get his health. So if health of top is greater than the health of our current robot dies. So health of top is going to go down by 1. So minus equals 1. And our health of our current robot is going to be set to 0. Now we simply just need to stack.push our top robot back onto the stack. So in this case scenario, the robot I that we were looking at loses his battle. So the top of the stack right moving robot beats the left moving robot. So the right moving robot loses 1 health, the left moving robot dies, his health is set to 0, and then we put the right moving robot back onto the stack. Otherwise, if our health of top is less than our health of our current robot, so our left moving robot has more health than our right moving robot, we are going to do health of I minus equals 1 because he won his battle. And health of our top robot is equal to 0. And we don't have to push him back onto the stack because his health is already 0. So in this case scenario, the left moving robot wins. He loses 1 to his health, and that's it. We're going to go back through the while loop as long as S isn't empty. He's going to continue fighting all the right moving robots that are behind him. So if we don't have if our top robot doesn't have more health than our current robot, and if our top robot doesn't have less health than our current robot, they have the same health, so both are destroyed. So we're going to do health of top is equal to 0, and health of I is equal to 0. So they're both gone. So this handles all of our scenarios. If it's a right moving robot, we automatically push him onto the stack. If it's a left moving robot, we're going to pop whoever is on the stack as long as the stack isn't empty and compare his health until either he wins, he kills all the right moving robots, he dies, his health is set to 0, or their healths are the same and they both die. So once we do that, we can simply go on to determining how we're going to put the robots back in the order that we got them. And this is simple. So we're going to do a for loop for each I is equal to 0 as long as I is less than our n value. Again, we're going to pre-increment our I value. If the health of our I is simply greater than 0, that means the robot is alive. What we can do is we have our output list and do out.add healths of I. And boom, now we have a list containing all of the robots that survived, and we can simply return our output list. So if we run this, so let's pass our test cases, and it passes our solutions. So let's try this in Python. So for our Python solution, we're going to go for a very similar to pretty much the exact same theme. So n is going to be equal to the length of positions. And then we're going to have a OG position, which is going to be equal to a list. And it's going to be for the range of n. Then we're going to have our result, and that's going to be an integer array, and a stack, which is equal to a deck in Python. Now we simply want to sort our OG positions. We're going to do dot sort, and the key is lambda of x 4 positions of x. So that's going to sort our OG position array by the positions array. Then we're going to have a for loop for the I in OG position. We are going to do if directions of I is equal to an R. Simply just do stack.append our I value. Otherwise, while our stack and healths of I are greater than 0, we're going to do top is equal to stack.pop. And if healths of top is greater than the healths of I, then what we're going to do is simply do healths of top minus equals 1, healths of I is equal to 0, and we can do stack.append top to put him back into the array. Else if healths of top is less than healths of I, that means our current index wins. So healths of I minus equals 1, healths of top is now equal to 0. And then we can have our else if both robots have the same health. Then we can do healths of top is equal to 0 and healths of I is equal to 0. So that covers all of our situations. Now we simply just need to put it into a list to return. So we could do for I in range n if healths of I is greater than 0, we simply append it to the list. So result dot append healths of I. Makes it pretty simple. We can return result. If we run this, my bad, I'm a Java professional. So if we run this, passes our test cases, and if we submit it, passes pretty much all the solutions. So thank you. Follow for more daily LeetCode solutions.